All right, let's try to predict our last set of problems. So for the first example, we have C10H22 plus O, that should say O2. We have a combustion reaction here, so you have to just write CO2 plus H2O for your products. In our second example, we see we have potassium iodide and chlorine. I have a single element, so this is a single replacement reaction, which means I need to go ahead and identify my ions. Potassium is positive, iodine is negative, and then chlorine has a negative charge. So in this example, the iodine and the chlorine are going to trade places with each other. Potassium is going to partner up with the chlorine, and iodine will be left on its own. We want to go back and make sure that we have neutral compounds, so check our charges. Potassium is a +1, chlorine is a -1. That's a neutral compound. And then we look at the iodine, and because it is a diatomic element, we need to include a subscript of 2. In our third example, we have aluminum and nitrogen. Both are single elements, so the only option is for them to combine into one compound. This is a synthesis reaction. So I have ALN. Now we need to check that it's a neutral compound. Aluminum is a +3 and nitrogen is a -3. So ALN is indeed a neutral compound. My last example, iron 2 sulfide plus hydrogen chloride, is a double replacement reaction because I have 2 compounds. Let's go ahead and identify our charges on each of the compounds. I'm going to start with hydrogen and chlorine just because it's easier. Hydrogen a +1, chlorine's a -1. Now for the iron sulfide, we know that sulfur is a -2. Iron is a transition metal. In this case, there's only 1 sulfur and 1 iron, so iron has to have a charge of +2 in order to cancel out the sulfur. My positive ions are going to trade places, so iron is going to partner up with chlorine, and hydrogen is going to partner up with sulfur. Let's go ahead and check our charges so that we can make a neutral compound. Iron's a +2, chlorine's a -1, hydrogen's a +1, and sulfur's a -2. When I crisscross my charges, I have FeCl2 plus H2S. Again, at this point, you'd want to go and make sure that all of your equations are balanced.